Okay, let's take a look at the second part of the applications of quadratic inequalities into variables. So the first part here is just to help you think about the math language and what it's going to look like. Some of them are pretty basic. We know less than is just going to have that math symbol of less than. Greater than is going to be greater than. Less than or equal to, we should know. Greater than or equal to, we should know. Now, when we get to not more than, that's where it gets a little more complicated. If it's not more than, then that means that it is either less than or still possibly equal to. If it's not less than, then either it's going to be greater than or equal to. If it exceeds something, it can't be equal to it, it has to be bigger. If it is at least something, then it is going to be bigger than or equal to. If it's at most, it's going to be less than or equal to, and the last case is just not equal to, which means that it can be bigger than it, can be less than it just can't actually be what that value is. So let's take a look at a couple of examples of this. If I'm writing an algebraic expression for each, if I'm representing all numbers that are less than 50, I can just say x can represent any of those numbers and they just have to be less than 50. If the sum of two numbers cannot exceed 12, then if I have x plus y, two different numbers, if it can't exceed 12, it has to be either less than or equal to 12. A number decreased by 7 is at most 4, well, then that means that the number decreased by 7 has to be less than or equal to 4. It can't be bigger than 4. If a number decreased by 5 is not more than another number increased by 2, not more than is just another way of saying less than, or possibly equal to. So a number decreased by 5 is less than or equal to another number, let's call it y, increased by 2. If it says the sum of two numbers is both more than 5, but also less than 25, then I know it's going to exist between the two. So I would say that 5 has to be less than the sum of the two numbers, which also has to be less than 25. Okay, putting it into practical application. So it says a satellite dish is 60 centimeters in diameter and 20 centimeters deep. So obviously this is going to be my x stretch, this is going to be my y. The dish has a parabolic cross section. Locate the vertex of the parabolic cross section at the origin, which means that if I have my grid, then this is going to be where my vertex is, right at the origin. And sketch the parabola to represent the dish. Well, it's going to come down, it's going to come back up, and I know that this distance has to be a total of 60 centimeters, and this distance has to be a total of 20 centimeters, which means that I have 3 exact points that I can already see. I know that my points are going to be negative 30 and up 20, positive 30 and up 20, and 0 and 0 for the vertex right across the origin. If I want to determine an inequality that shows the region from which the dish can receive signal, well, it can only receive signal in here, which means that this is going to be the region in here where I can actually receive this signal. So first I got to figure out what my actual equation for this is. Well, I know that p value is 0, q value is 0, so it's going to be y is equal to ax squared. And then I just need to solve for what the a value is. So I'm going to say that if 20 is equal to a times 30 squared, then 20 is going to equal 900a. And when I divide both sides by 900, a is going to equal 1 over 45 as a reduced fraction. So I can say that y is 1 over 45 x squared, and because it's filled in above this region and can touch anywhere along here, I'm going to say it's going to be greater than or equal to what that is. All right, for example 3, in order to get the most revenue from registrations for a camp, An adventure company needs to have as many campers as possible at a price per camper that is reasonable. If 15 people sign up, the price per person is $50. The registration fee is reduced by $2 for each additional camper above 15. So it gives us what the equation is, and we're going to graph out this inequality. It already has this value set for us here, so when I'm graphing it out, I'm just going to put this into my calculator as y is equal to bracket 50 minus 2x times 15 plus x, and I'm going to graph this out. I can go to my table of values to find some exact points that exist. Well, the y-intercept is going to be at 750, then it's going to come up to the vertex at 5 and 800, then it goes to 10 and 750 again. We have 15 and 600. We have 20 and 350. And we have 25 and 0. So here's my quadratic. Because the inequality included the equal to, I'm going to include that. And it said that it's shaded in below, or when y is less than. So here's my shaded in region. Actually here, I'm going to use a highlighter so I can do the next part. There we go. Okay, when it says, what is the maximum total of registrations that will generate a revenue of at least $500? Then that means that I want another subsection where y is going to be greater than 500. That is just going to be in this top region up here. And if I want to know how many I can get, well, I can just put in the second equation as y equals 500, and I'm going to solve for where this intersect is. When I solve for the intersect, the exact number is going to be about 17.247, but let's say that it's going to be 17 people. If I have it up to 17 people, then I will have generated revenue of at least $500. Okay. So, for example 4, it's talking about a bridge that's supporting an archway that's supporting a bridge, where if I have a bridge that's coming through here, I have an archway that exists underneath it, and then I have a river down at the bottom. It gives us what the equation of this is. Y is equal to negative 0.0048x squared plus 1.2x, where y in meters is the height of the point above the river, and x in meters is the horizontal distance. If I'm writing an inequality to represent the cross-sectional region between the arch and the river, it wants to know this region in between the arch and the river. So if I'm just looking at that region, I'm going to say that y has to be less than or equal to negative 0.0048 x squared plus 1.2x. If I have to state what the restrictions are, well, I know that I don't want to dip down into the water, so I also know that y has to be bigger than or equal to 0. When I'm graphing it into my calculator, I'm going to graph the equation. Y is equal to negative 0.0048 x squared plus 1.2x. I'm going to have to change my window settings. So the window settings that I'm using for this are negative 50, 300, because we know that it's going to stretch 250. Our question already told us that up here. And I'm going to say that each one of these is going to be worth 50. For y, it's not going to stretch as big for the numbers, so for y, I'm going to say that's going to be negative 10, positive 100, and each value, or the scaling, is going to be 10. I'm going to draw a sketch of what's on my calculator, and even though it does have a little bit of a negative region in there for me to see the intercepts, I am not going to shade in that region because I know it's actually just going to come up here, come back down, and look something like this. All right, so if it says the tallest mast of a ship is 37 meters above water level, so there's our y, can the ship pass under the arch when it is 50 meters from one end? There's our x. So if we're using the inequality that we established up here, we're going to say that 37 for our y has to be less than or equal to negative 0.0048 times 50 squared plus 1.2 times 50. Now, because it says specifically that it wants it to be under, we're going to eliminate that equals to as well. We're going to say that we don't actually want it touching, we want to see if it can exist underneath. When I multiply this out, I'm going to get negative 0.0048 times 50 squared is negative 12. And 1.2 times 50 is going to be plus 60. So 37 is less than 48, which is true. So yes, the ship can pass. If I look up at my graph, that point is going to be somewhere in this region here, where it is going to work at 50 and 37. Okay, hopefully that all made sense to you. Once again, let me know if you have any questions or concerns, and go ahead and try the rest of the practice on page 496.